In this video for section 13.1, we're going to talk about something new called the chi-square goodness of fit test. So what we're using the chi-square goodness of fit test for is to test whether a distribution follows something like a normal or a binomial distribution. So in a lot of problems that we've seen so far, we have made the assumption that the population is normally distributed. But how do we know that we can make this assumption? That's what we're going to look at here. So when we're using the chi-square goodness of fit test, we are comparing the number of values from the sample data set in a given range to the proportion of data values that we would expect to find in that range if the data were normally distributed. So the comparison part will be done by Minitab, but we are going to need to use Minitab to calculate the proportion of data values in each range, and we're going to see how to do that here. So we're going to create a table in Minitab with the following headings: the classes, which is the ranges of data values, the observed frequencies in each class from our data set, and the normal distribution probability for each class, which we will calculate using Minitab. So this is a slightly more complicated process than those that we have seen so far. So we're going to do this business application problem from page 503. We have a company that makes wood moldings, door frames, and window frames, and a saw automatically cuts the boards to the desired size. So the saw manufacturer claims that the differences from target are normally distributed with a mean of 0 inches and a standard deviation of 0.01 inch. So we're going to use the chi-square goodness of fit test to test this claim with a 0.01 significance level, or alpha. So as usual, first we need to write our null and alternative hypotheses. So my null hypothesis is going to be that the data are normally distributed with mean of 0 and standard deviation of 0.01 inch. So this is the claim that the manufacturer is making. My alternative hypothesis is that this is not true. So the data are not normally distributed So this is different from the tests that we have done so far, which have been tests that just look at the mean of a data set. Now we are looking at the shape of the entire data set and whether it is normally distributed with a given mean and standard deviation. So basically the same as my null hypothesis, except I'm adding the word not normally distributed. So I have my Minitab worksheet here with the data. So I have the sample, I have the actual width and the target width of the boards, and then the difference. So the target width for each board, it was supposed to be cut to 2.875 inches, and we see that some were cut slightly larger than that and some were cut slightly smaller. And this difference column is the column that I'm going to use because that's what I'm making my claim about, that the difference is normally distributed with mean of 0 and standard deviation 0.01. So I'm going to create my table here. I'm going to use the headings of classes and observed values and normal distribution values. Now my classes are going to be based on the mean and standard deviation of the data set. So I'm going to make ranges that I expect that the data values are going to fall into. So the way that I'm making these classes is by taking the mean and subtracting the standard deviation, and then subtracting the standard deviation again, taking the mean and adding the standard deviation, and then adding the standard deviation again. So my first class is going to be less than negative 0.02, negative 0.02, and under negative 0.01. Make this big enough here. Negative 0.01 and under 0. 0 and under 0.01. So this is the mean plus 1 standard deviation and the mean plus 2 standard deviations, and then greater than 2 standard deviations away from the mean. Sometimes this table will be given to you, like in the homework question about this section, and then you can just use the table that's there. But that's where these values come from. So now what I'm going to do is count how many in the difference column are in each of these classes. Now I could go and do that by hand, but there are 300 data values here, so that would take a long time. So I'm going to use Minitab to help me out with this. I'm going to go to Stat, Tables, and Tally Individual Variables, and make a tally list of the difference column with counts. Oops. Select that to make sure it's in the box, the variables box, and click OK. And now I can use this list, and the nice thing is that it's in order, and I just have to add the numbers together to figure out how many are in each class in the range. So less than negative 0.02, I see that there are no values in the data set that are less than negative 0.02, so that's 0. For negative 0.02 and under negative 0.01, I would add 14 plus 19 plus 3 plus 6. That's going to give me 42. Negative 0.01 and under 0, I'm going to add 23 plus 16 plus 9 plus 18 plus 39 plus 17 plus 11. That'll give me 133. And 0 and under 0.01, 25 plus 22 plus 9. 0.01 and under 0.02 would be 19 plus 16 plus 9 plus 6 plus 16, which is 66. And 0.02 and over is just these 3. So I'm adding those numbers together. Obviously, I did that a little bit quickly, but you just need to add the numbers or use a calculator if you would like. So that's how I get the observed column. Now what I need to do is get the normal distribution probability column. So the way that I'm going to do that is also using Minitab. I'm going to go to Graph, Probability Distribution Plot, and View Probability. You might remember this from Stats 1, which may seem like a long time ago, but we did this in Stats 1. We're using the normal distribution. Our mean is 0, and our standard deviation is 0.01. Now I'm going to click on Options, and the first row that I'm going to fill in is going to be the less than negative 0.02 row. So I'm going to use a specified x value here. That's a left tail, and put in my x value, negative 0.02. Click OK. And I see that that probability 0.02275. I'm going to round that to 0.0228. Then I would repeat the process for the rest of the rows of the table. So I'm going to go to Graph, Probability Distribution Plot, View Probability, mean and standard deviation should still be there. Now I'm going to do middle for the ones that are between two numbers. So this one is between negative 0.02 and negative 0.01. Click OK. And the probability there is 0.1359. And then the next one is between negative 0.01 and 0. And I get 0.3413. So the rest of these are going to be mirror images of the ones that we already did. You can check them using Minitab if you like. You would just use the same process that we just did. But to speed things up, I'm just going to put these numbers in. Okay, so now my table is complete. So I'm ready to do my chi-square test. So what I'm going to do now is go to Stat and Tables, and I'm going to go to the chi-square goodness of fit test one variable and click on that. Now in the observed counts box, I'm going to put the observed column where I tallied how many were in each range in the data set. So I'm going to click on that and hit select to put it in the observed counts box. And then under the test area, this is where I'm putting my calculated values for what they are supposed to be for the normal distribution. So what I need to do is select specific proportions, and then in the box, I'm going to put my column that contains the normal distribution probabilities. So select that, and then I click OK. And here are my results. So I see my observed and test proportion here in this table. That should be what I picked out of my spreadsheet. And then I see the results of the chi-square test. So the chi-square number here, that's the test statistic, or you'll see a symbol, which I'll draw for you in a minute, the symbol for chi-square, and then the p-value, which, as we know, the p-value tells us whether to reject or fail to reject the null hypothesis. So my chi-square value is 54.8152. So I'm going to write that over here. It's kind of looks like an X with a squared, fancy looking X is the letter chi. So the chi-square value is 54.8152. Switch to my other marker here. 54.8152. And my p-value 0.000. So the chi-square, or the test statistic, the homework will ask you for that. The p-value, we are comparing to our alpha, which our alpha here, our significance level is 0.01. Not to be confused with the standard deviation, which is also 0.01. So since p is less than alpha, we can reject the null hypothesis. So what does rejecting the null hypothesis mean? Well, it means we have evidence to support the alternative hypothesis. So we have evidence that the data are not actually normally distributed. With mean of 0 and standard deviation of 0.01. So what does this tell us about our situation, or our saw that is cutting our wood pieces? Well, it probably tells us that the manufacturer is incorrect because their claim is, we have evidence that their claim is not true. So that could mean that there is something wrong with the saw.